Hi, my name is John Thuma, and this is my second video on Aster. Today we're going to talk about Aster for Affinity, and this is one of our most powerful features of the Aster platform and the SQL MapReduce paradigm that we have. So let's just jump right into it. So we've all heard about this beer and diapers affinity, and it's a joke that that beer and diapers sell well together. And basically, this is affinity, is that what things go together or have a co-occurrence relationship across people or groups or things. So what we're going to do is we're going to show a SQL, an ANSI SQL way of doing this, as opposed to a way you could do this in Aster. So if you look here, this is an affinity metric or an affinity model, and Z divided by X on ij equals CBij, and the descriptions of what those things mean are right here. The main point though is that as CB here approaches 1, there's affinity across item I and across item J. As it approaches 0, there is not affinity across I or J. So Zij is both products in the basket together. So if I were walking down my grocery store and I was throwing in items into my grocery basket, I proceeded to check out, and other people were also doing that, which they do, and there were relationships across multiple persons' baskets. We could use this model to be able to determine how that works. Now if you look below, this right here is a SQL command that looks like this particular model. So you can see Zij, Zij, Xi, Xj, which is right here, which is done in SQL. Fairly simple SQL statement to write, and then you have the product of that, which is CBij, and then the rest of the statement. The limitation is that it only works for two products, 1 and 4. So what that means is it's pretty challenging that if I had 2, 3, 5 years worth of basket data from a grocery store retailer, and that was across 5 years, that could be a significant amount of data to run for just 2 products against 5 years worth of data. What I'd have to do is I would have to create another table to keep item correlations in it. So 1 and 4, 1 and 5, 1 and 3, 1 and 7, and so forth. And then all the combinations of unique items would have to be in that table. And then I'd have to loop through for each combination of items to be able to get to this one metric. And that's quite challenging. And I've actually done this in the real world. And it works, as long as there's nothing else running. And it may come back against that table of items. It may come back in maybe 60 hours, 45 hours, depending on the size of the data set and the amount of data that you're running against. With Aster, it's different. With Aster, I just have one line of code, and that one line of code is right here. So select star from C filter, and of course I have all my connectivity information, which we can obfuscate or we can hide. My input table is V sales fact, which means that this is a view of all my fact sales data coming from my grocery retailer, which includes the item header, the basket header information, as well as the items in the basket. So the output table is the name of the table that I'm actually going to create as a result of my running of this cFilter statement. The input columns are the products in the basket, or the items that I placed in my basket. So remember my previous example that I was adding items to my grocery basket. Well, as I went to check out, these products would be in my transaction ID. The UID, or the basket ID, is my basket identifier that contains the products to be compared with other people's unique baskets. So this is really the basket header unique identifier. And I could say max at 1,000, but I don't have to, and drop table yes. So that means I'm going to drop my output table and when I run this again. If you notice, and this is the one statement to do all of that. Now the neat thing is that I could just go after March of 2013. I could do March 2012 and March 2013, so I can get a same store sales kind of thing. And the neat thing is that I just don't have to limit myself to baskets. This could be diseases and the genes they share. This could be patients and the drugs they take. This could be a lot of different ways of spinning this into a useful type of analytic. Select star from C filter. This is the metaphor. So, if we're all familiar with ANSI SQL, remember SQL MapReduce, which is patented technology by Aster, uses a metaphor very similar to ANSI SQL. Select star from C filter. Whereas I would normally see a table name here, C filter is one of the analytical functions. It's available in Aster. Pretty nifty stuff. But as you can see, here's the rest of my input columns, my output columns, my table names, and my join columns and whatnot. So that's how all of that works. And this would be what my output would look like. Visually, I'd have my item 1 here. I did a join with the item master so I could get the actual name of the product. And then I also added and accumulated another the business unit ID, which would basically be the kind of like a product hierarchy. So if I wanted to roll this up, and then product 2, this has a relationship with this product. So and then I have all of my different metrics that are over here, and so forth. So the first 4 columns are items that are paired together in their relationship, and they may be strong, they may not be strong. Primary metrics are counts of items occurring across the batches, and then count B, items occurring together across the batches. So, and then I have all these other affinity metrics: score, support, lift, confidence, and z-score. And those things are highly documented right here inside of the Aster Analytics manuals. All the Aster Analytics are very well documented. Now, another thing that's neat about this, and I'll let you go back, get the download of the documentation. Another thing that's neat about this is that it comes with a visualization engine. And this, again, is a multi-node affinity analytic. So I'm allowed to see what items belong with other items. So you can see the thickness of this line, and these are items that sold together. It looks like a sigma diagram, almost looks like a graph diagram. And it is, very much so is. And then you have the edges here that denote the strength of the relationship between those items. The redder and the thicker that line, the stronger the affinity between those 2 items. So you can see here. And then there's a whole host of other, this is part of Aster Lens, and there's a whole host of other metrics that come as a part of this. So I think that's pretty neat stuff. And the way you can do this with 3 lines of code or less, you can get a lot done. You can do a full market basket analytic with Aster very quickly. Oh, and the code runs in about 10 to 20% of the time as it would with standard ANSI SQL in the example that I showed you earlier. So that's pretty powerful stuff. That's about it. So thank you very much, and I appreciate it.